Hey Algebra 1, welcome to your first online homework video. I won't be in class tomorrow, so I thought I'd give us a quick 10-minute walkthrough of the lesson, and then you'll have class to work on homework. So let's talk about this. Yesterday we talked about the definition of a function and what that meant. A function has an input. When you input a value, you get a value out, which we call our output. And remember, for each input, there's exactly one output. So if I wanted to graph this function, some of you may have graphed stuff like this last year, but we're going to actually start by graphing with a table. Now you can plug any value into X. You can input any value that you'd like. In general, when we make tables, it's nice to work from -2 to 2 so we can see a lot more of the graph. So let's go ahead. Let's start by inputting some of these values and seeing what we get out. So I'm going to start by inputting -2. When I do that, I would get f of -2 equals 3 times -2 minus 1. Remember this new function notation, f of -2 equals -6 minus 1. F of -2 would equal -7. And that is my output. When I input -2, so when my input is -2, I get out -7. Alright, and let's proceed. If I go ahead, I find f of -1. We can do some of this mentally. 3 times -1 is -3. Minus 1 is -4. I'll still write that on this problem. So here I would get -3 minus 1, which is -4. So my input, when my input is -1, my output is -4. Let's do the rest mentally. When I input 0, f of 0 would give me 3 times 0 minus 1. 0 minus 1 is -1. When I input 1, 3 times 1 is 3, minus 1 is 2. 3 times 2 is 6. 6 minus 1 is 5. Notice the increase each time here is an increase by, what? 3. Which kind of indicates that this is going to be a line. Each time my x goes up 1, my y goes up 3. My x goes up 1, my y goes up 3. Let's go ahead, let's plot these points. Here's my x value, -2, -7, -1, -4, 0, -1, 1, 2, 2, 5. If at any point I'm going too fast for you, just pause the computer, slow down, and think about what I'm writing. Because we chose these values, we could have chosen anything. We could have chosen a half and found a point, -1/2 and found a point, -20 and found a point. But we don't need to find all of them. Once we get the general shape, we can draw the line through the points and assume that this is the graph of our function. So next I ask you, at x equals 3, what would y equal? So let's think. Let's go to our graph and say when x equals 1, 2, 3, here's x equals 3, what does it appear that y equals? Well, 1, 2, 3, 4, 5, 6, looks like 7. Alright, at x equals -3, let's count it. 1, 2, 3, what would y equal? 1, 2, 3, 4, 5, 6, 7, 8, looks like about 10, alright? -10. It asks, is there any x value that would have more than one y value? Well, ask yourself, -1, there's only one y value. -2, there's only one y value. -3, there's only one y value. By the look of this graph, no matter where I go on x, there's always one y value. So it passes that test that each x has exactly one y. Now, how do we tell just by looking at a graph whether or not it's a function? Well, what we can do is we can take a vertical line and run it anywhere through our graph. Alright, and that vertical line should only touch my graph one time. Think about it. If I brought my vertical line here at about -2 and asked you at -2, what does y equal? Looks like it equals about -1. That means at that x I have exactly one y. There's nowhere I can bring this vertical line where it would hit more than once. Therefore, yes, this is a function. If I take my vertical line over to this next graph and ask, does this ever hit more than once? We can see, yes, in fact, it does hit more than once. So if I asked you the question, when x equals 1, what does y equal? Well, it could equal 3 or -3, and we know by definition each x can only have one y, so no, this is not a function. We call this the vertical line test, meaning if we take a vertical line and we pass it through our graph, if it hits more than once, it's not a function. Let's check on 3. If you pass a vertical line through here, it only hits once, so yes, this is a function. Look at 4. Function or no? Let's pass some vertical lines through here. Does it ever hit more than once? No. So yes, this is a function. Alright. Here, even though my graph gets kind of steep, it still looks as though if I pass a vertical line through here, it'll never hit more than once. So yes, this is a function. Alright. Of the next 3, only 1 is not a function. Can you tell which? Let's go ahead, let's skip this graph. This is the integer function, and we'll talk about that when I'm back. So decide which on your own, which is not a function, and I want you to compare that with your partner when you get to class tomorrow. See if you agree. Go ahead, flip to the back side. Next it says graph the function with this specific domain. We're going to talk about this in a little bit, but domain are possible x values. That means I only want to see the graph at these specific points, nothing else. So when I'm given a specific domain, I have to use those values in my table. I want to just go back to the front of the notes. Notice they didn't give us a domain on the earlier ones. They didn't tell us what x should be. So we just chose -2 to 2. Those are often points that math teachers will pick just so you get a good sense of the graph. If you're not given values, let's choose -2 to 2. And if they give you a domain, use what they give you. So in the same way, we're going to go ahead, we're going to input these values and find out what our outputs would be. So let's go ahead, let's start by inputting 0. F of 0 equals 2 times 0 minus 3. So f of 0 would equal 0 minus 3, and f of 0 would equal -3. So my first input value gives me an output of -3. Continue on. I want to find the value of f of 1. I'm going to input 1 for x. I'm going to find what I get as my output. 2 minus 3 is -1. When I input 1, I get an output of -1. Right, let's do the rest mentally. If I input 2 into my function, 2 times 2 is 4. 4 minus 3 is 1. If I input 3, that's not what I meant to do. If I input 3, 2 times 3 is 6. 6 minus 3 is 3. 4 times 2 is 8. 8 minus 3 is 5. Now, I just want to remind you, they gave me a domain, which means I only want to see the graph at those 5 values. So when I graph this, 0, -3, 1, -1, 2, 1, 3, 3, and 4, 5, I will not connect the dots. Alright, I only want to see the graph. I only want to see the graph at the given domain values. Alright, I'm going to get you started on this last one and then I want you to graph it on your own. This says given the verbal rule, the output is 1 less than the input. Alright, my output is y, or sometimes we are now using this notation f of x. I'll start with y. So the output, y, is in math means equal, is 1 less than twice the input. As a reminder, the input is x. So 1 less than twice the input would be twice x, and 1 less, so take away 1. So here we've written the equation that represents the rule. If you'd prefer to start using function notation, you can go ahead, instead of y, you can write f of x. And I want you to make a table. If you can't remember what your table value should be, flip back to the front side. Remind yourself, I've said it a couple times in this video, and make your graph. I hope this goes well. Tomorrow in class, you'll have your partner to work through the homework. Have a good night.